So get back again to the geomechanical modeling workflow. So the next step will be the mechanical earth model. The mechanical earth model, not a direct output from the geomechanical model, but it's very significant. You cannot do the other parameters or the other steps, including the fracture or even the well pore stability, without calculating the mechanical earth model. Mechanical earth model simply, it includes both rock strength parameters and the elastic properties parameters for the rock. So it includes UCS, tensile strength, friction angle as rock strength parameters, while the elastic properties including Young's modulus, Poisson's ratio, bulk modulus, and shear modulus. So it's mandatory. Many uncertainties while calculating them. Normally we use the compressional and shear velocity to calculate the mechanical earth model, and again it's called dynamic mechanical earth model or mechanical or dynamic elastic properties. While converting them to the static mechanical earth model or elastic properties, will need some empirical relations. So once you have the good data and the core data, you have to do your analysis by yourself. The next step is to calculate the fracture gradient. Again, at each step, you have to use all of the previous data to calculate. So the fracture gradient, we're going to use the pore pressure, the vertical stress, and the Poisson's ratio from the mechanical earth model, assuming that we will use the Eaton equation. The next step is the stress magnitude and orientation, and as you know, all of you know that normally we use the seismicity data from the regional publication from the seismicity data. If it's not available, and if you are dealing with some image data in the nearby fields, it will be significant to identify the stress magnitude and orientation. The next step is to identify the well pore stability, where you can identify the shear failure analysis and the fracture pressure. And if you are dealing with such unconsolidated sand formations, you will have to deal with or to proceed a sand production study showing for the reservoir engineering what is the critical drawdown pressure they do not have to exceed, trying to avoid the sand production while oil production. So let's have a look about one case study.